This is an actual piece of cable from the Golden Gate Bridge. The bridge cables connect Marin County over there and San Francisco over here. The bridge allows the people in Marin to use the resources of the city and the people in the city to use the resources of Marin. And the vehicles going up and back across the bridge cables are carrying people, things, and information from one location to the other. You might think of this as a kind of local area network. In principle, it's very much like a computer local area network. Today, we continue our special two-part look at computer networks on this edition of the Computer Chronicles.
The Computer Chronicles is made possible in part by CompuServe, featuring an online reference library, Wall Street reports, at-home shopping, airline reservations, games, and hundreds of other services. CompuServe, helping people get the most from computers. Additional funding is provided by McGraw-Hill, publishers of Byte. Byte's detailed technical articles on new hardware, software, and languages cover developments in computer technology worldwide.
Stewart, I'm worried about the bandwidth of this network.
George, we'll get to your problem in just a minute. Welcome to the Computer Chronicles. I'm Stewart Cheifet, and sitting in for Gary Kildall this week is George Morrow. George, I suppose the original network cabling system was string and two cans. Every kid's played with this kind of thing. It's really more like the phone system, but the phone system is in fact a pretty good analogy for a computer network, isn't it?
You're right, Stewart. The original phone system was a party line system with multiple phones connected to the same line. Very similar to the bus structure of today's networks, where multiple computers are connected to the same single wire that goes from one to the other. In fact, the analogy is even better than that, Stewart, because there's multiple standards today in networks, and there used to be multiple telephone companies, and it was very difficult sometimes to transfer a call from one company to another.
George, today we're going to focus on Macintosh networks. We'll see Macs talking to Macs, and we'll see the ultimate in connectivity, Macs talking to IBM PCs. We begin today by paying a visit to the Arthur Young Company in San Jose, California, where they're beta testing something called Mac Link.
When the accounting firm of Arthur Young & Company decided to install an integrated network, it was faced with some special problems. At the San Jose, California branch, incompatible hardware is divided into different parallel networks on 3 floors of offices. On the 8th floor, Macintoshes are everywhere, but on the lower floors, IBM compatibles have the upper hand. Today, the company is testing a new gateway that allows any user to communicate with any part of the network.
What we're really addressing here is the ability to take an existing network that was designed exclusively for a single environment, DOS in this case, and gatewaying that to the Macintosh world. What we're able to do is we have to dedicate a machine. It is a gateway. It's a DOS box. It has an ArcNet card in it. It has an AppleTalk card in it. Talks to both networks. And the bottom line is it is, for all intents and purposes, seamless, because any file that's published over NetBIOS is available to whoever has the access to it, is also available to anybody on the Macintosh side through that gateway machine.
3Com file servers presently link different machines and different networks over the telephone lines. While the so-called interbridge talks to all the networks, the decision to keep different machines led to frustrations and delays.
I guess the biggest problem was just coming to terms with the true capabilities of the network, not pushing the network beyond what it was expected to do. The problem used to be things like corrupted data and file allocation tables that go out of whack and things like that. The problems we face now are just expending a lot of time trying something that was never intended to work, and you get to the end and the bottom line is it doesn't work, and you've just spent a lot of time trying it. So I think it's to the point now where it's not causing the users problems. It's causing the people who are trying to push the technology problems.
The Mac to IBM gateway is not yet perfected. It took several tries to transfer a file for this demonstration. But its appeal is undeniable. Through the interbridge, a user can retrieve a formatted document, send a memo, or electronic mail literally to anywhere on the network. At Arthur Young, Macintoshes outnumber IBMs, still an unusual sight in the business world. It's common to see accountants lugging Macs back into their offices from field trips to clients' offices. And in spite of some persistent bugs in the Mac to IBM network, the company plans to expand its system to provide network access from remote locations and a wide area network to link offices around the world.
Joining us in the studio now is Chris Bryant, Workgroups Manager at Apple Computer, and helping Chris at the other workstation over there is Andrew McClung, Marketing Specialist with Apple. George?
Chris, networking came to the Apple when, or networking came to the Mac when it first came out, but a lot's happened since then. Why don't you bring us up to date on where things are in networking in the Mac too?
Okay. Over the past few years, we've moved from the first network implementation, which was called the Apple Talk Personal Network,
yes,
through a series of additional services for the Macintosh in the network environment, to now actually new network implementations for the Apple Talk network system. One of the ones we'd like to talk about here probably is the Apple Share File Server.
You're going to give us a demo.
Right. One of the first things that users notice about file servers typically is that they're different to use than using local resources on their personal computer. One of the things we've tried to do with the Apple Share File Server is make the use of the file server as transparent as possible to the user, to make it as similar to using local resources as we can.
Chris, excuse me, describe the configuration we have here before you get going.
What we have is a Macintosh 2 workstation, the color monitor here. This is connected to the file server over the network. The next is a Macintosh 2 that is actually functioning as the file server. It's running the Apple Share software, and you can see on its screen that it has a server status display. The next is the LaserWriter Plus printer, and then in front of Andrew is a Macintosh SE workstation, which is also connected to the file server.
Okay, now show us how it all works.
Okay, the local hard disk is represented by this icon, and when we open that up, we can see folders, or the equivalent of subdirectories, that are stored locally on this Macintosh 2.
Each one of those little cards is a subdirectory.
That's right, and if we open that up, we can see whether, well, that one's empty.
Okay.
We can see the programs or documents that are stored inside by their respective icons.
Those
That's
are
right.
icons for files.
And we could have additional folders stored within that. Now, when we open up the file server volume, you'll notice that the remote information, the representation of that, is nearly identical to the local information. And in fact, we work with it in just the same way.
Now, Chris, one of those folders is gray.
That's right. Some folder, in the Macintosh, there's a metaphor for resources that you don't have access to are grayed out. For example, if we go up into this menu, you'll see that some of the selections are grayed because we can't use those at this time. There's nothing in the trash, so we can't empty that. The same way, a folder that we can't have access to is grayed, and when we try to open it, indeed, we get a message that says we don't have the access privileges.
And you don't have access to that because?
Because the owner, who has control over giving access to other users, has kept that private. In fact, this is a special kind of folder. This is what we call a drop folder. I can make changes to that folder, but I can't see what's inside. This is sort of like analogous to the mailbox that's on the corner. You can go and put things in, but you can't see what's inside there. And it might be useful for if you were doing status reports or performance reviews, you can submit those, and no one but the manager has access to it.
In fact, Chris, if this were really a user-friendly system, I'd be able to take something up here and just move it down there on the screen.
Well,
is that possible?
That's exactly right, George. That's the way we designed it.
You work for Apple, George?
When I click and drag on this folder here, I can actually put it on the server, and it copies right across to the server environment. Or if I wanted to, I could move it into that drop folder. And you'll notice that when I do that, it says that I won't be able to see it once I put it there. But if I click OK, it's now inside that folder.
Well, I guess what I expected there is for the metaphor to work right, and Apple has made it work right.
Okay, can we get, say, Andrew to create something over there and show us how that would be reflected on your workstation?
Right. Now, you'll see that if you watch down here on the server volume, that when Andrew creates a document on the server or a new folder, that after a few seconds, what he's created on the server actually shows up on my screen.
There it is, yeah.
So there's a dynamic updating. But you'll notice that the way it was created private to Andrew. Everything that a user makes it starts out being private. But because he has control over access privileges, he can give me access to that folder. And he pulls down a window there where he has the opportunity to give access privileges to other users, and you'll notice now that folder is white. I now have access to it.
Chris, let me ask you something about these two metaphors, if I could. This is the metaphor of the resources on the file server. This is the metaphor for the resources on the local system.
That's right.
Are these pictures reversed over there on the file server?
Well, the file server itself, an AppleShare file server is a dedicated server. We do that for a couple of reasons. Number one is performance. The file server is giving resources to a lot of users on the network, and so in order to maximize the performance for the users who are taking advantage of it, we make it a dedicated server. It can run additional services in that same piece of hardware. For example, LaserShare, our print spooling software for the laser writer, can run in conjunction with AppleShare in a single server.
But it couldn't run applications.
That's right.
Its entire purpose is to serve for file servers on the network.
It's a network server, that's right. Now the fact that we implemented it in standard Macintosh hardware we think is a plus, because as users increase their needs, they can move up from a Macintosh Plus to an SE to a Macintosh 2, which we have here.
Now, do you need the Mac 2 as the file server in this kind of system?
Well, it'll run, as I said, in a Macintosh Plus as a server or a Macintosh SE, but we think that the Macintosh 2 makes a better server platform because it's a higher performance machine.
It's strictly a performance issue.
Yeah, right, and expandability. The Macintosh 2 has expansion slots and let users add other resources, other services in the same box.
Is there there's no structural difference between this? It's the same hardware, whether this was a server or whether it was a station.
Exactly.
So, in theory, if you wanted to take the technology a step farther and perhaps give up a little on performance, this could be both a station and a server.
Well, you can do that. There are issues involved with running applications on a server where if the application has trouble, everyone on the network sees that impact on the server, whether it's even there or not.
But the server is just a Mac 2.
That's right. And in fact, because of the AppleTalk network system, the way that it's architected, the same server functionality is now running in VAX VMS computers from DEC, and so that you have transparent migration from the Macintosh Plus all the way up to a DEC VAX.
Gentlemen, we're going to be back in just a minute, and we're going to show you how you can use AppleTalk to have the Mac talk to an IBM PC. So stay with us. We're back in the studio with Chris Bryant of Apple, and now over at the other workstation is Bill Berner. Chris, a couple of questions before we get into the new demo. What's the protocol, the hardware technology you're using here for the networking?
Well, in this case, the Macintosh 2 workstation is connected to the Macintosh 2 file server using EtherTalk, an Ethernet implementation of the AppleTalk network system. The Macintosh SE workstation previously and now the Compact Portable are connected to the server using the AppleTalk Personal Network, which is a lower cost implementation with lower speed.
Chris, these screens and the metaphor, does this have anything to do with the Ethernet, or is it, what part of it does it play in the operating system or the operating environment?
Well, the AppleTalk network system protocols are designed into every Macintosh and the LaserWriter also, and what you see here is consistent across the entire Macintosh line, whether you're using an Ethernet network, whether you're using AppleTalk Personal Network, or some of the other media that we run AppleTalk networking across, which includes fiber optics and telephone wires. You always see the same thing. We try to make that networking transparent. It's integrated into the Macintosh operating system.
I see.
Okay, Chris, as you mentioned now, we don't have an SC over there anymore, but we have, pardon the expression, IBM compatible, a Compact Portable 2. And show me now how you can have the Mac and the MS-DOS machine work together.
Well, Bill can show now, he's connected to the server, and he can do a directory of the server volume. Now, one of the important things with AppleShare PC, the software product that makes this possible, is that it represents the server information in the appropriate format or context that the user's workstation requires. So when he does a directory from the server, he sees the same folder names as subdirectories that we see, except for the ones that are too long to represent in the MS-DOS 8.3 format, in which case the file server, AppleShare, truncates that name and provides an appropriate MS-DOS name to the workstation. And Bill's done that directory, and now he can show that using, he'll launch Lotus 123, the application, and he can open a document from the server and make changes to the document and save it on the server, and I will be able to go in and run Excel and access that same document directly.
So he's got a 1, 2, 3 spreadsheet up on the Compact.
That's right.
He's going to save that file.
That's right. He's saving it to the server, And you notice that he does it transparently. It's just like he's saving it to a local disk.
Right.
And we see now on my window that worksheet has appeared on the Apple Share volume, on the server volume. And now, if I run Excel, and we are now in Multifinder, we're in Excel, I can open the document on the server. So we now get the Macintosh standard file, the Apple Share volume is up, and there's that worksheet, sales.wks, and we can open it, and Excel will do a conversion of that WKS file directly. And in fact, using Excel, we can immediately create a chart from that information. So we click chart, say OK, and we actually get a graph.
So you're doing a graph on a Mac 2 from the spreadsheet he had from Lotus 123 on.
And that what's important there is the file that we opened was a Lotus 123 file.
Right. Chris, I'd like to ask you a question about the cost. I guess some of the networking capability is built right into the Macintosh.
That's right. The network, the hardware that's required to do networking, and the software protocols are integrated into every Macintosh and into the LaserWriter also, so that all you need to connect workstations using the AppleTalk Personal Network is a $75 connector per node.
And any Macintosh can act as a file server.
That's right. A Macintosh Plus, Macintosh SE, or a Macintosh 2.
Chris, we're out of time.
That's
George,
great.
thank you very much. Now, universities have been a logical breeding ground for local area networks. Faculty and students spread all over the place, lots of resources that need to be shared. One good example is at Stanford University in Palo Alto, where Wendy Woods reports.
Stanford University has one of the largest campus computer networks in the country. Some 1,300 computers ranging from Macintoshes, sophisticated workstations and PCs, to VAXes, microVAXes, and IBM mainframes all talk to each other via the Ethernet network. In various closets across the campus, you can see the gateways and repeaters, in lay terms, the traffic cops that make the system work across the vast distances required. This impressive network even spreads into the dormitories, where students have access to bulletin boards, job banks, even the full bibliographic holdings of the Stanford University library system. They can do assigned courses in programming, even send mail to their instructors or anyone else on campus. Networking Director Bill Yunt says tying all these diverse systems together with Macintoshes came with a few trade-offs.
The way we've chosen to do that is by writing software that runs in a compatible fashion with the other machines on the network that share the protocol family called TCP/IP, and allow a Macintosh to sit on an AppleTalk network and be connected through the AppleTalk network to our Ethernets, so that they look to the rest of the network as though they're physically connected to the Ethernet.
Macintoshes are slow and have only single-tasking operating systems, but students love them. They're easy to operate and good teaching machines. The most common way Macs are used is in classrooms. In small local area networks such as this interactive classroom, the Macintoshes share software programs stored in a designated file server. What's on the instructor's machine can be viewed on all the students' Macintoshes, or his Macintosh can be used to view what's running on individual students' computers. So far, French, history, and computer literacy have been taught this way. Linking all computers on campuses is an increasing phenomenon throughout the nation's top universities. MIT and Carnegie Mellon are two other outstanding examples. But the people here say they're ahead of the rest because they've found a way to make their network useful, with top researchers and freshman students alike. At Stanford University, for the Computer Chronicles, I'm Wendy Woods.
With us in the studio now is Jan Lewis, president of the Lewis Research Corporation, and next to Jan, Tim Baharan, executive vice president of the Microcomputer Group at Creative Strategies. Jan, we've seen over these last two programs now a lot of spiffy new local area network products, but we still hear complaints about complexity and slow performance and reliability in networks. Have things changed really? Have we made much progress in LANs?
Actually, we have made a lot of progress in LANs. There's still a tremendous amount to go in terms of all the aspects you talked about, the complexity, the cost, cost, the performance, etc. But we have made a lot of progress. And I think a lot of it has to do with your perspective. If you're sitting there in an environment where you have lots of different architectures and lots of different machines, the kinds of connections we have right now are still inadequate to meet your entire environment. On the other hand, if you're sitting there in a department, let's say, and you have some people using Macs and you have some people using IBMs, and you have a product now like Apple Share that really does give you a fair amount of file transferability and certainly the commonality in terms of the file server, to somebody in that position, they couldn't do that a couple of years ago. To them, it's a major step forward. Again, if you take the global look at the whole industry, there are hundreds of different machines, architectures, etc., and to hook them all to each other,
It's got to be complex.
it exponentiates
But I've never
itself.
seen anything as natural as this Apple environment.
The implementation on this is truly elegant. First of all, in terms of the user interface itself, it really is easy. It literally is easy to figure out. The idea of having the share, you know, what's sitting on the server down here, being able to do various things with it. It literally is intuitive, it's easy to learn, easy to remember, etc.
Tim, what do you think about
Well, what you're actually seeing with this Apple model is what we believe will be the future, which will be intelligent network managers.
Yeah.
And if we are really going to see this whole kind of interconnectivity work, we're going to have to see these various LANs working close together with a much cleaner user interface and a lot of power. And what Jan said earlier, depending on your perspective, if I'm from a mainframe or a mini multi-user environment, the LANs that I see today are not, I don't consider that significant. They have not come far enough to me. But if you're coming from a place where you couldn't connect things together 2 years ago, these LANs look like they're wonderful.
Now, the presentation manager that will be here someday from Microsoft, do you think we'll have an environment that'll make local area networks on the PC world as natural as it is here on the Apple?
Probably, although the big issue is going to be memory. Presentation Manager, Microsoft Windows, X Windows, anytime you start talking about this kind of network function, you're talking about a tremendous amount of power needed at that CPU level, and
a lot of
memory
memory
as
gets
well
chewed
as
up.
processing speed.
Jan, Tim, I'm sorry we're out of time. Thanks very much. Thanks for joining us on this special two-part look at local area networks. Hope we'll see you next week.
Access file this week, Apple Computer is suing Hewlett-Packard and Microsoft. Apple says their unique Mac display and screen images are copyrighted. The company says Hewlett-Packard and Microsoft infringe on that copyright with New Wave and Windows. This case could be a long one. Hewlett-Packard issued a statement saying they would fight the suit vigorously. Microsoft's statement says they are convinced the case has no merit and they deny any copyright infringement. For the first time in the computer industry's history, we will be seeing prices going up, not down. A survey of peripheral board makers shows the shortage of DRAM chips is pushing prices on graphics and memory boards up. If the shortage keeps up, system makers are expected to be next. Everything from 64K to 1 megabyte chips are up in price, sometimes double from what they were at the beginning of last year. Not only are chip prices rising, but so are tempers. Atari is going to court against Micron, a supplier of DRAM chips. Atari says Micron Technology of Boise, Idaho, failed to honor a telephone order for 3 million DRAM chips at $3.75 each, then tried to sell the chips to Atari at a higher price. Atari wants damages from Micron for breach of contract, bad faith, and violation of antitrust laws. Micron says the company has no comment except to say they've been served with court papers. It's merger mania. Tandy Corporation announced March 16th it will pay $55 million to buy Grid Systems of Fremont, California. Grid is one of the first makers of powerful laptop computers. The buy gives Tandy a respected top-line laptop. You could compare it to Chrysler buying Maserati. Grid PCs won't be sold through Radio Shack stores. Only Grid salesmen will sell PCs once the deal is done, says a Tandy spokesman. Now, for a software review, here's Paul Schindler.
I'm a professional writer, but do you suppose I'll look up a word in a thesaurus? No way, who's got time? I do, and you will if you get Webster's electronic thesaurus. No, this product won't sound all that exciting unless you use a word processor. Then it becomes invaluable. First, Webster's is the biggest thesaurus on the market. It can look up 40,000 words and suggest 470,000 alternatives, yet it occupies no more disk space and operates as quickly as smaller thesauri. Its nicest feature is that Webster's provides one or more definitions for the word you try to replace, then suggests synonyms for each definition. Other thesauri include only a simple, undefined list of synonyms. Another nice feature, if the noun is plural, the choices offered are plural. As wordsmiths say, the inflections match. Webster's Electronic Thesaurus, $90 from Proximity Technology in Fort Lauderdale, Florida. For the Computer Chronicles, I'm Paul Schindler.
One software developer is taking a different approach to OS2. Rather than wait for the release of OS2's Presentation Manager, Timberline Software is developing a character-based emulator of the Presentation Manager. The company designs programs for the construction industry. They will use the character approach in its first OS2 product. The idea is to allow Timberline's customers to start off with the menu interface and keystroke and mouse actions. That will become standard in Presentation Manager applications. AT&T is trying something new again. The company launched a small footprint PC clone called the AT&T 6300 Work Group System. Prices range from $1,411 for a single floppy model to $2,091 for a single floppy and 20 megabyte hard drive. The new model only needs 70% of the desk space of previous models in the 6300 line. Pirates better beware. A $50 bounty is being offered by the Software Publishers Association for information about pirate bulletin boards offering commercial software. SPA wants the name, address, and phone numbers of the system's operator, a printout of the commercial software the board is offering, log-on information including passwords and the date, and put all this in writing. Informants' identities will be protected. A similar bounty program last spring closed down 30 boards and resulted in $3,000 in bounties. That's it for this week's Computer Chronicles. I'm Cynthia Steele.
The Computer Chronicles is made possible in part by CompuServe, featuring an online reference library, Wall Street reports, at-home shopping, airline reservations, games, and hundreds of other services. CompuServe, helping people get the most from computers. Additional funding is provided by McGraw-Hill, publishers of Byte. Byte's detailed technical articles on new hardware, software, and languages cover developments in computer technology worldwide. Transcripts of the Computer Chronicles are available online on CompuServe. Type Go Chronicles at any CompuServe prompt. If you'd like the CompuServe access number in your area or a free booklet describing how to use online services, call 1-800-848-8199.